I'm Krug, Solutions Architect from NetSCOUT, and this section I'm going to talk about the challenges faced by IT, DevOps, and security in the NSX software-defined data center. So the thing I wanted to focus on here is what do you deploy in these environments is applications. That runs the business, so they're important. So they're changing. So historically, and even today, of course, but I don't like to call them legacy, you had the classic N-tier design, the three-tier app, web, app, database, as you can imagine. But they're moving across to a different type of architecture, microservices architecture, things like Docker, Kubernetes, and those sort of aspects. So there's change going on there in terms of how you deploy applications, for good reason, because it makes it easier to maintain them, easier to automate updates and make sure things are working. So I understand that things are changing, which makes it complicated to and difficult to troubleshoot things when things go wrong, of course. The other angle here is obviously the virtualization story. The things, applications are moving platforms, so they may be traditionally on ESXi hosts, vCenter and stuff like that. They may be migrating over to the software-defined data center with technologies such as NSX, which is kind of the headline of this sort of section, or other SDDC technologies. But they also may be moving to the cloud, the public cloud, AWS, Azure, Google. So they're going to move. But what's interesting about all they're going to move, it's not everything's going to move. You end up with a hybrid cloud, a hybrid implementation. A bit of NSX here, a bit of ESX there, a bit of Google there, and a bit of Amazon there, and stuff like that. So lots of components that make up your application. I mean, they don't all move away from your on-prem stuff, maybe for security reasons, maybe for data protection reasons and those sort of aspects. So there's good reasons that they're not all going to the cloud, although, of course, if you speak to the cloud vendors, they want everything to go in there because it'll all be secure and all be perfectly working all the time. However, that said, you end up with this mix, this hybrid environment. And the trouble with that, of course, is there's lots of different tools that you use to try and keep this up and running. Each tool has a different specialist who can understand the different metrics that they get. And it's just difficult to manage. So wouldn't it be good? Wouldn't it be good if you had something that could give you a visibility in that hybrid environment in a consistent way, using consistent metrics, so that no matter where the application resides, what it communicates, you can get visibility of, one, the communications, the connectivity of the applications, the dependencies of the applications. So you've got clients talking to servers, talking to app server components, talking maybe to some shared services like DNS and Active Directory. And they're all distributed in different parts of that hybrid cloud. Some may be on-prem. And this is an example of a NetSCOUT visualization. We call it service dependency. This is discovery, so we're looking at the traffic profiles, and we're actually able to see how these applications are communicating across the different layers. So at the top, we might see the users coming in to various web servers, coming in there, talking to various database servers, talking to various shared services like DNS, NTP, DHCP, whatever it might be. The point here is that we're able to use the same instrumentation technology, so we're getting the same metrics wherever we're observing this information, bringing it together, and even in this example, we're showing where users who are accessing Azure servers, the data actually sits in the corporate data center on NSX. But we can see that dependency because we can see the communication between those applications, because that's the one thing that these things have in common. I just wanted to do a very quick thing on NSX before I talk about technology. And I'm not going to dwell too much on this one, but the whole perspective of NSX is to remove the need to have like physical firewalls, physical switches and routers, and actually do that in software. So the idea is you don't have this tromboning effect. You virtualize it with the NSX platform, and it means your apps and your servers can communicate over this software-defined network, independent of what infrastructure is going on underneath. Say no more on that one, because you all know that. But the thing is, when it comes to actually looking at how these applications are made up, at the end of the day, they're still ESXi hosts with VMs. There's a multitude of ESXi hosts which are connected over a network, and there's also potentially other networks, public networks that they also connect to. So you get this mix. You get this mix of what's known as east-west traffic and north-south traffic. So what the idea is here is that there's a lot of teams still involved in making sure everything's working. From application teams, security teams, to server to network teams. They're still involved. They don't disappear. They still have a job to do, thank God. Because it's important to understand how your application is architected. Remember, dependency discovery and things like that. And also how your network's architected, because these applications might talk across data centers, across clouds. That's where the north-south infrastructure comes in. Then it comes to what's the nature of the issues that actually might transpire. So I'm getting down to the idea of saying, okay, so what, right? Why is it important to have visibility of east-west, north-south, and all that sort of thing? Because each of those teams need answers to certain questions, certain problems, so that they can know whether it's they're responsible for it, or make sure that the right team gets involved in solving the problem quickly. So we're all about reducing MTTR, of course, mean time to resolve, and understand what's going on. So first thing to understand is which team do you direct the problem at? Then they can use whatever tools or our tool to actually deep dive into all of that. So they're looking at it from different perspectives. And I think the point that NetScout really have here is that we offer a solution which is applicable to all those expertise, whether it's application or security or network or server teams. And I'll, again, describe that ASI technology, which gives us and reveals that. But at each layer, we have different teams. Applications teams. Okay, number one, why is my application performance suffering? Okay, that's an obvious one. Why is my business not running effectively? So that's a big problem, especially when you consider the application is distributed across everything. It might be microservices, it might be multi-tiered, it might be dependent on shared services like DNS and Active Directory. But he's still got the problem. Why is it slow? The other thing or problem or bit of information that would be useful to have is how are the applications communicating? What are the dependencies? Where are things? Because in order to understand how application performance is suffering, you need to understand how your application is made up. So you might design it one way, but I like to say that as built is never the same as designed, and things are moving all the time. Mm-hmm. And you've got other things and applications running on the network infrastructure as well. So that information is hugely valuable. Security. So I've tackled two areas of security here. One is, how do I feed my security tools? So if NSX has got this tightly firewalled concept where no traffic goes through that network unless it's got permissions, how do I get access to that information that I need to feed my security tools? It's a problem. It's like, how do you do it? Are my security policies working? So if you're thinking about NSX, yeah, that's number one, isn't it? Or not number one, but from a security standpoint, I've set up my policies. Are they working for me? Or is there, let's say, other traffic floating around the network, which is increasing that attack attack surface, and potential for infiltration or exfiltration of data. So are my security policies working is really important. Then you've got server and network teams in terms of, okay, server teams, you've got multiple hosts, you've got traffic communicating across the hosts. They kind of want to think about, how do I engineer my servers appropriately? How do I engineer my network appropriately? A good example might be you design an application. Okay, at an application layer, you may have a multi-tier app tier talking to a database tier. Fine, brilliant, that's going to work. But you don't know where those components are going to be deployed. Imagine you've got the database in one data center and the application in another data center over a link. The network team sees more Oracle traffic going over his network, so he engineers it and grows it because he's seeing more Oracle traffic. Right? The app team just knows it's working. Wouldn't it be nicer if they could streamline that a bit and maybe not have to get the network engineer to increase the capacity of his network, but put it on the same data center, maybe put it on the same host or something more sensible than that? But again, that's all about visibility and understanding how these things are communicating.
So how do you provide visibility and assurance into platforms like PCF, PKS, Docker, and native Kubernetes?
So that's a very good question, and I've actually done some work in that one. And oddly enough, I will talk about our technology, and and it's we have visibility of that east-west traffic. In the case of like Kubernetes or Docker, we sit in containers, and we get visibility through host mode and privilege modes to actually see that north-south or east-west traffic that's going between.
Are we talking true east-west traffic or just east-west traffic that traverses over the network? So like
true east-west traffic.
So like in the VMware context, I could have two objects that sit within the same VSS, and thus they won't generate real east-west traffic without having NSX in place. But within the containerized model inside of Kubernetes, for example, that could even be greatly diminished to where we may not necessarily have it be picked up by other monitoring tools. That's why I'm curious how you.
Yeah, no, that's a really good question. So in both Docker and Kubernetes, we're able to look at the network interfaces, the virtual network interfaces that make up that east-west communication within a host in a cluster or externally as well. So we see that traffic in the same way that we would see by almost spanning the traffic inside there.
Excellent, thank you.
And then the beauty of that, and we'll go on to that, is that we're using the same technology. It's ASI, and I'm building up to ASI wherever your applications are hosted as well.
So I have a question.
Sure thing.
So I've been implementing SDN solutions for over 4 years now. And why most customers buy it is for microsegmentation. So evaluating all the customers, financial, healthcare, retail, manufacturing. So all with compliance issues, security issues. But the reality is, how many are actually using microsegmentation today? Hardly any. And the reason for that is because they don't have application dependency mapping information. So I think that use case alone is very compelling, in addition to the security. Is it going to integrate with NSX to help with that, or?
Yeah, so right now, I mean, that's a great concept, because what we're doing now, we've just announced our partnership with VM in terms of having an embedded NSX probe, basically. We called it vSCOUT NSX Edition. I'm going to get into great detail with that. That gives us visibility via the security policies, and we get given the packets in that NSX environment. So it's basically, as one VM talks to another one through the NSX plane, if they're part of the vSCOUT, NetSCOUT security policy, we see that traffic that's going through that. We then analyze it and then provide those metrics to give you the user interface and the workflows to look at dependencies and some of those application performance metrics to solve problems like that.
And you just become a visibility scout and getting the flows and such like that, and not an enforcement mechanism to actually go in and establish and create the policy. Is that fair?
Yeah, absolutely. It's very fair. So a good example would be we'll see the flows between one VM and another. So that will be dictated to by the NSX firewall policies. Absolutely. But it depends how you write those policies as to whether they're very, very tight. As you were saying earlier on, is people don't do it because it's hard to do.
That's right.
Or they leave holes to make it easier for them to do that. So what we would do is, yes, sure, the application has been designed to communicate in one way, but we would discover what else is going on that the security policy is letting through only because it wasn't configured tight enough. So that allows security infiltration. So although you could imagine that the idea is, of VMware, is to stop things in their tracks because they can't communicate across. You're reducing that attack surface. That's the idea. But it only works if you've defined the policies effectively.
Are you guys working with them? Because one of the goals with NSXT with VeloCloud integration is writing a common policy framework. Are you guys working with them on the policy framework? Because it doesn't do you any good to be able to see that there's more holes that are open if no one's actually using it, because it's sitting idle. It's still open from a security standpoint. It just happens that your app isn't using it, so that doesn't really tell you a lot. But if you can read the policy framework that actually they're defining with an NSXT to push into VeloCloud, then you can actually validate against that and say, like, actually, the way it's written and what we're seeing traffic-wise, this is the delta, this is the negative space that's in there, and here's the positive space that's in there too. Because that's, to me at least, if you're trying to solve that problem, that's greater value than just simply validating what packet flows are actually happening.
So there's a...
Because VeloCloud has a packet sniffer effectively built in. So, I mean, that value is more diminished with NSXT integration, right? Because it's
Well, with the
distributed.
VRNI implementation, and I also curious how it applies with an NSXV implementation as well,
Right.
in addition to NSX.
Right.
So with VRNI, you could effectively get network topology. You can look at ports that are open. You can see firewall rules. It maps out dependencies of the network. And
What's the value that we're getting out of this that's a head and shoulders above that, basically? Right?
or does it? Yes. So that's one question. The second is, we're kind of hearing about the NSX integration, and there is the open question between V and T. But from a VRNI perspective, it answers a lot of those questions around what needs to be open, what talks to what, why, and what is that hierarchy?
Yeah, I think NetScout provides the validation side, which is actually saying I can see the packet flow, I can validate against that, versus just you're telling me what the intent-based policy conformance
It's
is.
one thing to have knowledge, it's another thing to have intelligence, right?
Yeah.
And it may be that because VRNI gives us knowledge, but NetScout seems like it probably gives us intelligence to actually tell us what and why. Or maybe, I don't know, Ray will
Yeah,
tell us.
I guess we're gonna find
I'm getting on. I reckon my next slide is going to start talking about that, so that's really timely. And I think because some of the technology stuff is very different from VRNI, and that's kind of the key thing. The technology is fundamentally different, which is the important thing. And VMware is difference, and you'll see that difference as I start to explain it, hopefully on my next slide. Yes.
I don't know about that.
Now I'm back. Do you know? Yeah. So this is going to introduce that ASI technology, adaptive service intelligence, and I think the important thing to recognize is the thing that binds together the applications wherever they are is communication, which is a network, which is wires, whether they be physical wires or virtual wires. So what we're able to do with our technology is look at that packet data, which is unstructured, difficult to interpret, but translate that into something that is easy to interpret. So we just transform the wire data, what we call smart data. So what is that smart data? I don't know whether I said adaptive service intelligence is what ASI stands for. Smart data, number one, it gives you that visualization, that service dependency based on traffic flows. So you'll see that in action in a little bit more. But it also gives you application performance metrics as well. So that's another differentiator. What do I mean by that? So we see the packets flying around, we translate them to smart data, which gives us a sense for all the sessions that are going on and that interaction, the responsiveness client-server across those tiers of the application. That responsiveness is both network response time and application response time. So we distinguish between effectively that flight time, how long it takes to traverse the network, as to the difference that the server is responding just to that request. So we can do that. We know whether the infrastructure is in a way in fault or whether the application is at fault. So that's one thing in terms of latency that we can actually distinguish between. The other thing that we can do is deep packet inspection. So it's not about looking at packets and you having to look at packets. It's about us interpreting those and making them smart. A good example might be we're able to take a look into the packets and look at message types, errors that are going on. So we see in a web world 401, 501, that sort of thing. But in an Oracle world, you'd have a ton of application responses that are coming back. MySQL has its ton of responses, MQ, whatever. You name the protocol, you name the application, we can interpret that and actually see now errors, number of errors, the different type of errors, as well as the responsiveness of those.
Is it reading the data itself or just the header?
So both. Header, you get response time, timestamping, and that sort of thing, but you don't get application latency by looking at that. So you need to go deeper dive to see what's going on, the message types that are going on, and the responsiveness going on.
So when I see packet capture forensics and packet forwarding, the first thing I'm thinking of integration with some type of and feeding it off to an IPS or something along those lines, which will then allow it to issue down a packet reset, or a TCP reset on something, because I see a known threat or problem that's outside the constraints of what I'm expecting. Do you provide that as part of that?
Yeah, no, that's the whole point of this, and actually the whole point of this slide, because the idea is, number one, visibility. We've talked about that. VRNI has visibility. It doesn't have those application performance metrics. It does have the service dependency concept, but we do it from a perspective not from infrastructure and hop to hop to hop. We do it from a perspective of more a logical view in a hybrid cloud environment. And then back to your question in terms of packet capture. So we're getting visibility of those packets. We can forward them on for exactly the reason that you want to do. It may be an IPS, it may be any security tool that's doing analytics, it may be even our own application, because we don't necessarily store the packets unless you tell us to store the packets to do that forensic analysis over historical time spans. So we can control how much data we use to store those packets.
You've got the integrations, the capabilities of integrations through API or partnerships in order to leverage security constructs outside yourself.
Absolutely right. I mean, typically we'll forward them through like a GRE tunnel or something that they're used to consuming. We can send that either directly to the tools or to what we call, we have a packet flow switch, which is an aggregation switch. We can send it to that, which you can then feed it out to other tools as well. There's a lot of infrastructure technology that we've also got beyond the smart data. But yeah, absolutely right.
I'd be curious deeper on how I would actually try to do the same type of flow, multi-cloud, hybrid cloud, GCP, AWS, Azure, as well as on-premises. Right.
How do you handle encrypted packets?
How do we handle them? Well, it depends. So we can actually do decryption, as it happens, if we get given the keys, right? If you get given the keys. So that's the one thing. The issue with decrypting traffic is, of course, load on CPU. So the more you decrypt, the more traffic you have, the more load. So you've got to balance that as to whether it's realistic to do. Number two is we still get a lot of information about what type of traffic that is and its latency and how much bandwidth it's consuming. So often that's enough to actually tell us what's going on with an application, and I think that's very important with encrypted traffic.
So you can do decryption without necessarily being the man in the middle, as long as you have the keys of the man in the middle to do interpretation in post.
Correct.
So do you use all of that in the public cloud environment as well? So same technology available
Absolutely
there.
right.
So AWS, for example, doesn't allow you to do sniffing.
Correct.
So what do you do there?
So I'll talk about technology in detail, but okay, we have a technology and it's called vSCOUT. So I didn't talk about that earlier on. I'll talk about it now, and then we can just recap some of the things that were going on. vSCOUT, think of it, it's actually an agent, but we deploy it in a couple of different ways. In an NSX environment, we deploy it as a service virtual machine as part of the NSX security policy, so we see the packets that way. Everywhere else, we deploy it as an agent in the guest operating system. So that allows us to see essentially the north-south traffic coming out of a virtual machine, which is the east-west traffic going in the cloud. So that agent, you notice we call it vSCOUT. In NSX, we call it, would you believe, vSCOUT NSX edition. And in the public cloud or everywhere else on bare metal, we call it vSCOUT.
What do you do for, Azure Container Services or, AWS's implementation for their native container service, because you don't have access to the host
So right now we don't do anything with those guys, with that technology, but there's nothing to stop us working more closely with Microsoft and those sort of things to actually make that happen. Right now we're just limited by what those vendors will allow us to get access to. So what are the cool things that we can do with ASI? So I've just literally thrown up a whole bunch of screenshots just to whet your appetite. And really the point is ASI is very versatile. It's smart data. So what we can do is smarter analytics. That's the point. So rather than trying to translate every packet and trying to create these visualizations, we're doing that on that smart data, which is a very, very efficiently processed KPIs, etc. So we've got dashboarding, service monitors to take a look at applications, microsegmentation, and see what's going on. I'll show you that in a demo app that I'll cover. Dependency map, you saw that right at the beginning with that hybrid cloud dependency map. Traffic discovery, we talked a little bit about that. So we see everything that's going over the wire, therefore we can discover the traffic and the communication going on there. Bunch of reporting, bunch of alerting. So that's both baseline alerting, so what's normal on a network on a Friday afternoon, does it deviate from that? Or threshold alerting, where you can set your parameters and then alert based on changes that you kind of want to watch out for. A bit more like analysis, situation analysis, we call that, but that's kind of a cause and effect. We're seeing a whole bunch of stuff going on. We're using that ASI smart data, interpreting it, and seeing where, if there's a lot more traffic coming here and a lot more errors coming here, correlate that together and say, okay, that's going on in your infrastructure, you want to watch out for that. So that's more, you don't even have to configure that, and it just cleverly comes up with a whole bunch of stuff that's going on in your infrastructure, may point you to some issues going on.
Can this operate in a multi-tenant model?
It certainly can do, yes. Then we've got some security type things. So, I'm not even talking about firewalling here. I'm talking about certificates. So when you do handshaking, that comes over the network. We can see that. So wouldn't it be good if we could interpret that and see whether we're using strong ciphers, seeing whether we're using out-of-date certificates, or the times to them going out of date. So often, I've heard lots of stories about people not renewing their certificates, their service goes down. We're seeing that on the wire data. We can tell you 5 days, 10 days to expiry on which server. We can tell you what ciphers are being used, what handshaking is being used, whether they're weak handshaking, whether they're self-signed certificates. So that's real security value in terms of just there to protect yourself against the time bomb of certificates expiring.
To add on to the multi-tenant question, from a dashboard perspective, there's sufficient RBAC granularity so that customers, if you have multiple customers, from a service provider point of view, right? If you're running NetSCOUT and you have multiple tenants within your environment, that you want to enable to have visibility into all of the things you have up there. Can you give that level of access to multiple tenants versus having the admin just have to respond to a ticket and say, here's the information you requested?
No, we can do that, yes. So we can actually segregate. There's so many different ways to do multi-tenancy. So we can actually segregate even one of our probes into, let's say, multiple VLANs and have each tenant on a different VLAN, and we can represent a dashboard tile associated with that VLAN and whatever application's going on there as an example, and then associate a user to having visibility of that particular dashboard as an example. But there's many ways of skinning that cat.
Well, tagged on that point, which is absolutely amazing, is from the alerting mechanism, do you have integration to tie into ticketing systems like Jira, ServiceNow, Service Mesh, or whatever, any of those types of things?
So yes, so we can configure with alerting, obviously the metrics associated with the alert, and then what we want to do with them, how we want to forward them on. The obvious one is email, as an example, but the other way we can do it is to trigger an event, which might be send it to syslog, send it to actually anything, if you see what I mean.
You can control the workflow and integrated APIs to tie it into whatever or you'd send it to Slack, for example, and have something act upon it.
Yeah, there's, it's just about, we can externalize that event, as it were, and then process it on to some other destination.
Because a lot of people just have SNMP trap, send email, and that's it. So knowing that there's some extended more capability is kind of important.
Yeah, and it's really important because we're not trying to substitute those systems, of course. We have an event manager, but people, a lot of alerts doesn't mean anything to the person necessarily operating this. They're not the guy that's going to react to that alert. It's going to be somebody looking at another console to do it.
Effectively, and especially in the multi-tenants and rollback way, is you can have certain alerts notify certain people and have a certain flow, and other alerts notify other groups. So that way, in a distributed kind of DevOps model, you're not flooding everybody with stuff that doesn't matter to them.
Correct. Oh, threat monitor as well. So this is something as well. I just wanted to, I did certificates, threat monitor. If stuff does get in to the NSX environment or any environment, we've got some sort of, I don't like to use the word signatures, but things like, they're like internal DDoS attacks that you might be getting that are attacking servers that are getting through. Because that traffic does get through, because it's often DNS, or it's a known port that is allowed to get through that they're hijacking. So we have visibility of those and allow you to see what's going on in the infrastructure. Remembering, of course, I was saying we are part of the Arbor solutions and the Atlas platform and some other technology that we have that protects that traffic getting in there. There's still ways that people can get in. That's why security companies exist, because you have to actually apply a security intelligence to what's going on in the infrastructure. So we have capabilities in there.
So is that using NetFlow and based on a threshold what the normal traffic is to determine a DDoS attack?
So, what Arbor does is a lot of the NetFlow stuff. What we're doing is we're using ASI to actually look at that. So ASI is not NetFlow. As I've said, it's like not just about conversations and port numbers and source and destinations. That's not what ASI is about. ASI is about client-server relationships, sessions, errors, latency of every session that's going on. So that's a differentiator between NetFlow and what we do. So we've got a much richer data source, a much more granular data source than you will ever have with NetFlow.
Okay.
So is ASI only as smart as the traffic that passes through your network, or does it have tie-ins where it's aggregating all the information from other NetSCOUT implementations and ASI implementations for artificial intelligence, machine learning? We've identified a type of threat vector that existed in one environment, and we can share that out to the other so that way they'll have an idea of what's going on, or other
I love that. That's great insight. And we don't do that today, but it's something that we can. I won't use the word easily leverage because I'm not in engineering, but absolutely something that we can strive towards because that smart data is so important. There's other things that we can do to integrate to some of the Atlas stuff as well to create signatures.
Because in a way that kind of looks at it as like it's a signature model, but it's not technically really a signature model because we're saying it's not a security signature-based solution. But there are characteristics, and as updates or new products go out, you upgrade from version X to Y, now you have a new error message that generates, and it's associated with a particular event. How do people then receive the updates? Do they have to do a full deployment upgrade? Is it a SaaS type application? Et cetera.
Yeah, a good example is a bad reputation DNS sites. It's a great example of exactly what you're saying. So we can create, we call them children of DNS, as it were, and we can actually, one good example is WannaCry. There's that on-off switch for WannaCry. We can actually create a child app of that. It's a known signature. We can see whether it's on your network. In fact, we've done that on a number of occasions when people have said, we haven't got WannaCry on our network. We do that. Say, well, what about these users we're seeing that signature, that domain name being looked up essentially like that. So that's the sort of thing that we could actually start to do, build up libraries of these, stick them in there, make them downloadable. Not there today, but it's not a million miles in terms of what we can do.
And one other question on the dependency mapping. Do you have the ability to model what it would be like if you took an application, moved it to a public cloud? Do you have the ability to model that and see what the links back would be, what the cost associated would be?
No. Okay.
Great feature to have.
I think it's a great feature to have, yes. I'm not sure I think there may be other tools out there that do that. I think we're all about, is real live traffic rather than specifically modeling it today.
And does this keep forensics? Are you able to go back historically and take a look at what happened?
We are. I get asked that question how long can you store this data? And ASI data is very lightweight. That's the whole point of the technology. It's not storing the whole packets. We also have the ability to store packets. So either way, right? So if ASI is lightweight, then we can easily do a year, right? Easily, right? But that depends on how much traffic we're monitoring. Are they 10 gig, 100 gig, or whatever it is? But if it comes to packets, then they could be very, very large. So we can store for as big as our hard disk and then roll around. But we have other technology which efficiently stores the packets on the disk. Because sometimes you are interested in the header and what type of data it is. You're not interested in the data, like the video, right? If you send a video across there, you're not actually interested in replay of the video, unless you are. You're interested in the fact that it was video. So we have technology that compresses that and just doesn't store the video, but makes it seem. But what's interesting about our technology is if you actually look at the packet, it looks like it's a real packet when it's with the data, but it's obviously not the data because it didn't exist. So it's transparent, but vastly improving the performance on the hard disk for storing that.
You do average trending over time, so at the current day I can see exactly what's going on, like the last, every second over the last 24 hours. But if I go back and look, today, a year ago, am I just going to see like the high and low points or such?
Yeah, you're going to see different granularity depending on how far you go back, because we have sophisticated roll-up mechanisms to group it back up, so it doesn't get out of control.
Yeah, I also have a similar kind of question. That can you sort of save the state? So if an application, there's a bunch of servers talking to each other in different environments, and then it sort of snapshots that state, that expected state of communication, so that if suddenly a server starts talking to something it shouldn't be talking to, then it highlights that, that's something different.
So I'll answer that as a half yes. So right now what we do, that service dependency map that I showed you is a point in time. we're able to save that point in time and then compare it with another point in time and see the differences. So a new server comes on, a new server's off, or whatever it is. So absolutely able to do that. Right now, we don't do that in an automated way that we're checking all the time. But what we do is an important step to what you're talking about.
Exactly. That's exactly why I'm asking, because typically you wouldn't like to take snapshots and manually compare at some point.
Yeah.
You want to know when it happens automatically. So maybe soon after installing the service, you know exactly which service should be talking to. At that point, if that state is taken, and anything that happens otherwise, then it gets alerted, then that would be a useful feature.
Yeah. I'm going to take that back to engineering. I've heard that same request before. The time difference we have already, alerting on that is going to be something that's really cool.
So do you build high and low watermarks and establish what the baseline looks like, or do we have to say, I want you to build a baseline from this point in time out, or something like that? Because I've seen some other products are like, you got to build it yourself. I'm like, I'm not building that. That's why I bought you.
And the beauty is, we do that automatically.
Perfect.
It's just there.
How is this, from a service provider point of view, well, I guess maybe just generally speaking, how do you license this? Right, so if you're using it in a data center and then in AWS or Google, as you grow your usage of it, how does that cost tail look?
So, our licensing model is extremely simple. I'm not going to give you costs, but I'll give you the high-level thing. There's kind of two components. There's instrumentation, and there's Ingenious One, which is the workflows and the management platform. So you buy Ingenious One, and you have so many licenses associated with that. Say it's 50 licenses and stuff like that.
Licensed by device, licensed by socket.
This is where so then you have instrumentation.
Okay.
So in a virtual world, you have technologies which record the packets and stuff like that. So in a physical world, you have appliances. So you then buy the appliances, but what they'll do is consume those licenses on that management platform. So for example, an interface is one license, and you might have Ingenious One with 50, so you can have 50 interfaces. When you go beyond that, because of scalability, then you can introduce what we call a global manager. So the global manager will then take on multiple Ingenious Ones. So the next Ingenious One, you get another 50 licenses.
Basic aggregate collector kind of situation?
Well, yes, you could argue it's that. So you'd have the global manager, which is the thing you would always log into, and then that has visibility of all the Ingenious Ones, wherever they're deployed, which each have visibility of all the probe technologies that they have.
But then the underlying part that we were discussing before around how physical or not sitting in an NSX type environment, you're going to load an agent inside of the guest inside the VM or the operating system. Is that the same? Those are considered kind of those instant entities, basically. 2 physical servers equals 2 licenses, 2 AWS instances, it's 2 licenses at that point.
Effectively, that it's effectively that.
But are you if I'm going physical, virtual, or virtual in certain cases? Is it going to be the same price, or is it going to?
No, it's going to be different. We have different models for our appliances. We have a appliance that we supply. We have a COTS type of style license where we just supply license. So we just supply, software and a NIC card. You supply the hardware, so that's another model. And then we have a virtual platform for the instrumentation. We call that vStream. So the hardware is called InfiniStream, and we've been clever at naming the virtual hardware devices vStream. So we have 3 different models: virtual model, COTS model, and appliance model. And it's up to customers to decide what they want to do. Service providers love the idea of having a physical appliance because it's capacity and performance. When you virtualize that, that takes capacity that they have to do. So we have an NFV in the service provider environment, depending on what platform you have, which is similar to what we do with NSX with our technology, but in an NSX environment.
So is that a consumption-based model, or do you buy the packs up front and then you have to grow into them, and when you max out what you purchase, you buy another bundle of,
However you want to do it.
Okay, so both are available?
Yeah.
Okay.
Interesting. Like per kilobyte, kilobyte.
Yes.
So what I wanted to do, in the essence of time, I wanted to kind of just bring you a little bit to speed in terms of our VMware partnership, hopefully I've given you a clue to some of the components and the graphical user interfaces and stuff like that make us quite interesting. ASI technology makes us interesting. So that's kind of why we've got a partnership with VMware and certainly the NSX edition of vSCOUT, which allows us to help our users migrate to these environments with confidence. So in the context of NSX, migrate to NSX.
That's the NSXV version of vSCOUT, or is it also applied to NSXT?
It's NSXV at the moment. NSXT, sorry, yes. We're working towards that.
Cool.